This is a question, a related rate problem involving how we find the angle or how an angle is changing. It's similar to one on the assignment, and this is a fairly standard problem. Actually, this is from an old exam, and it is a worked out example. Now I'm using my mouse here. My stylus is still not functioning. Apologize for that, but hopefully it will be on Tuesday. So this is the statement. Now the diagram is not given, but it's always a good idea to draw a diagram. It helps with the problem. So read it fully and determine what's given and what you need to find. And as I mentioned, normally the last part of the problem states what quantity is being asked for. So we're given here that a 5-meter ladder is leaning against the side of a house. The base of the ladder is right here is being pulled away at a rate of 3/2 meters per second, or 1.5. Okay, and we're asked to find the rate at which the angle, in this case theta, right here, between the ground and the ladder is changing the instant that the ladder is 3 meters from the wall. Now it sounds like a mouthful, but it's not too bad. So I drew this little diagram here. We know that x is simply the distance from the base of the ladder here to the house here. Y is a quantity I put here, this distance from the top of the ladder to the ground. But what are we given? And if you read the question, it says the base of the ladder is being pulled away at a rate of 3/2 meters per second. That's dx dt, according to our diagram. You can call it y or z or a or b, doesn't matter. And we're asked to find this angle right here. How fast is that angle changing the instant that the ladder is actually 3 meters from the house, or in this case, x equals 3. So that's what we're given. Now, we need an equation to relate these variables. Sometimes it's a volume question, it's an area question, and formulas will be given on a test or a final exam. But here we have to come up with the trig ratio. Now, I chose to use cosine here. I could use tangent or secant or cotan. But cosine is simply the adjacent side, which is x, right here, over the hypotenuse, which is 5. So that's the relationship. This is the equation we're going to use. Okay, and with all these equations, you always differentiate with respect to time t. Actually, implicitly differentiate with respect to time t. And we know that the derivative of cosine is simply minus sine. And since we're doing it with respect to time, it's minus sine theta d theta dt. That's the key part. And the derivative of 1/5 x, or x over 5, is simply 1/5 dx dt. If it was 2x, it'd be 2 dx dt, that kind of thing. Okay, so we need to find d theta dt. That's what we have to find. So we know that dx dt is 3/2, it's given, but we don't know immediately what sine theta is, but we can find that quantity pretty easily. So from the diagram itself, we know that sine is again the opposite side here, y, over hypotenuse. So opposite over, again, a trig ratio you've seen many times before. So we substitute in using the Pythagorean theorem. We know that x squared, let's show the diagram again, x squared right here, y squared here is equal to 5 squared. Okay, it's simply a 3, 4, 5 triangle. And we solve for y by plugging it in, and we find out that y is equal to 5. Sorry, 4. And what we can do now is take 4 and plug it in for y here, and we get that sine theta is 4/5. Now we have enough information to substitute back into the equation. So we've got negative sine theta, which is negative 4/5. d theta dt, which we're asked to find, here's the 1/5, and we know dx dt is 3/2. So we plug it in, and we do a tiny bit of algebra and solve for d theta dt, and we get negative 3/8 radians per second. Now units are not really important here. If you leave them out, that's fine. And I actually usually write a sentence at the end. That's optional. You don't need to do that. But it's basically stating the solution to the question. So hopefully this is helpful for your assignment question. And if it's not, you can certainly shoot me an email.